the smallest one of them all is called a neutron star. They are about 20 to 40 kilometers in size, roughly the size of a city, and they are the remnant of a massive star, at least 4 to 8 times the size of the sun. During the end of its life, the core of these stars collapses and keeps on collapsing until it cannot anymore. At this stage, the remaining core of these stars are so densely packed that electrons and protons in these atoms are mushed together along with the neutrons to form more neutrons. And that's why the name neutron star. Just 1 tablespoon of this neutron soup can weigh billions of tons here on Earth. The next one in the category are called white dwarfs. Similar to the neutron stars, these stars are also the core of a dead star. But unlike the neutron star that were born when a massive star went supernova, white dwarfs are born when a sun-like star reaches the end of its life and it sheds its outer parts, leaving behind its core, which we call a white dwarf. These stars can be the size of Earth, but they generally have a weight of a sun. Also not a different category, but similar to these are stars that are called black dwarfs. They are nothing but just white dwarfs that have taken their time to cool down and are now just floating around in the universe in the darkness. Our next category consists of failed stars called the brown dwarfs. Typically, they have a mass of 13 to 18 times that of the mass of Jupiter, but they are not massive enough to fuse helium into hydrogen yet, and that's why they are called failed stars. But if you look at them from the outside, they would have a similar size that of Jupiter, and all of its mass is basically compressing it to that size. You can find the next star in our category right in our neighborhood. The closest star to us is one of them, and they are called red dwarfs. These are considered one of the best stars to build a long-term civilization around, given some caveats. They can be around 15% the size of our sun, and since they are so tiny, the hydrogen in their core fuses into helium very, very slowly. This gives them a long life of about 1 trillion years, and they also emit most of their light in infrared, giving them the bright red color. The next one in our category sits somewhere between the red dwarfs and our sun. They are called orange dwarfs. They have a mass of about 70 to 80% of our sun, and this 30% difference in the mass can extend their life up to 70 billion years. Now, the next category are called the main sequence stars. They are white in color, and the best example of one of them is our sun. And yes, unlike what people believe, sun is actually white in color. These stars typically have a lifetime anywhere between 5 to 10 billion years, and our sun for that matter is already halfway there. It's 4.6 billion years old. Now, we are moving into the territory of giants, as these stars are typically 30 to 100 times bigger than our sun. They are called the red or blue giants. Now, you might be wondering, what's the difference between a red giant and a blue giant? Well, it's the temperature. The hottest star in the universe, burning at the temperature of 200,000 degrees Celsius, is a blue giant called Wolf Rayet. It's 35 times the size of our sun. And on the counter side, red giants are much cooler, around 3,200 degrees Celsius, but they are much more massive in size, typically around 100 times the size of our sun. But there is even a bigger category called the supergiants. They can be as big as 1,500 times that of our sun, but they have very little mass compared to their sizes. Like, one of the biggest stars in the universe that we know of is called UY Scuti. It's about 1,500 times that of our sun, but have a mass of about 10 times that of our sun. So why is that? It's because these stars are into their final phases of their life, so they have ballooned up to this size before they explode into a supernova. Now, you might be thinking that that's it. These are the biggest stars that you could find in the universe, but you are wrong. There may have been a category of stars in the early universe known as Quasi-Stars. Now, these stars were so big that their core couldn't handle the pressure and it collapsed into a black hole. They were so massive in size that they might have had a radius of 7,000 times bigger than our sun, which would make the biggest star in our universe look like babies. The good news is that these massive monsters only had a lifespan of about a few million years, so the last one exploded long time ago. That brings us to the end of this video. Thank you so much for watching it. As you can see, the video took a lot of effort to make, months worth of it. So I would really appreciate if you drop a like and let YouTube know that it's worth watching, and subscribe for more.